Welcome, ladies and gents. What we're going to talk about today is a heating and cooling curve when we look at something that is other than water. So up until this point, we've been doing our phase change diagrams for only water, but we can calculate the energy needed for any substance, no matter what it is, using the exact same diagram. Now, what you'll notice on the screen in front of you is you'll see all the information you'll be provided for any problem we ask you for heating and cooling curves. So things to pay attention to are we give you the specific heat for each state of matter, solid, liquid, or gas, and that's for use in your Q equation. And you'll use the number based on whether you're on the solid angle, the liquid angle, or the gas angle. We also give you the molar heats of fusion and vaporization, so we know how much energy it takes to melt and how much energy it takes to turn into a gas. And these two numbers are super important. These two numbers are going to identify your melting point and boiling point for you. So on your roadmap, you kind of know where your solid line ends and where your liquid line ends, so you can kind of figure out what state of matter you are. So we're going to look at how much energy, this should probably be must, how much energy must be added to vaporize 2.56 grams of iodine from 22 degrees Celsius to 200 degrees Celsius. So anytime you're doing one of these problems, what you want to do first is you want to draw yourself a roadmap so you can figure out where you're starting, where you're ending, and what conversions you need to use to get you there. So again, remember, this is going to be the melting point, this is going to be the boiling point, and instead of labeling them as 0 and 100 like we did with water, we're going to use these numbers. The melting point for iodine is 114, and the boiling point is 184. So we can see that we're starting at 22 degrees Celsius, which puts us down here, and we're ending at 200 degrees Celsius, which puts us above the 184. So remember, each point where lines intersect, that's going to end one calculation and a new calculation is going to begin. So our first calculation is going to take us to the melting point. Our second calculation is going to take us through the melting process. Our third calculation is going to take us to the boiling point. Our fourth calculation is going to take us through the boiling process. And our fifth and final calculation is going to get that iodine vapor to 200 degrees Celsius. So what I'm going to do is I'm going to get you started on how to do steps 1 and 2, and I'm going to have you guys finish with 3, 4, and 5. And once you get the answer, you'll show me, and that's how you get your homework for today. So the first thing that we need to do is we're on an angle, which means we need to use our Q equals ms delta T equation. And because this is our solid angle, we're going to use this specific heat for calculation number 1, because we are in the solid state of matter. So I'm always solving for Q. The mass for my problem is 2.56. The specific heat I'm going to use is 0.217. And then my delta T is just for this line segment. Just for this line segment, I'm stopping at 114. I'm starting at 22. So I'm going to do 114 minus 22 to get my answer. And that's going to be 92 degrees Celsius. So I'm going to go ahead and I'm going to do that in my calculator. So I'm going to do 2.56 times 0.217 times 92, and that gets me a total of 51.1 joules. Now remember, we want to convert this to kilojoules, so we're going to divide by 1,000, so that would be 0.0511 kilojoules. In step number 2, we're on a flat part, so we're going to do Q equals N times one of these numbers. Because we're melting, remember, that means we're fusing. So we're going to use this number first, and because we're going up, we're going to use it in the positive number. So we're going to do Q equals N times delta H fuse. So the first thing we have to do is we have to figure out how many moles this is. So we need to divide it by the molar mass. So we know we've got 2.56 grams of iodine, and when you look at iodine, iodine's molar mass is 126.90. But here's where this gets tricky. Remember, iodine is Hankelbrief, so it's actually I2. So we need to take that 126.9 and multiply it by 2. So the molar mass of iodine is 253.8 grams, and that's for every 1 mole. So if we do 2.56 divided by 253.8, that gets us to a total moles of 0.0101 moles. So now we're going to do that number, and we're going to multiply it by the delta H fusion. So we're going to Q equals 0.0101 moles times 15.52, and that's going to get us how many kilojoules we need to melt. And that's going to get us to a total of 0.157 kilojoules. So far what we've calculated is we know it takes us 0.0511 kilojoules to get us to the melting point, and that's going to take us 0.157 kilojoules to get us through the melting process. What I'd like you guys to do is go ahead and calculate the last 3 steps. How much energy we need to get to the boiling point, how much energy we need to boil, and then how much energy we need to raise that steam to 200 degrees Celsius. You'll add all 5 of those numbers together to get your total. Once you get your total, come see me, and if it's right, you get your homework for the night. Good luck, guys.